All right, welcome to the last one of the unit. Yeah. And then after this, you only got one more unit. You only have one more test. One more exam. I think we have a little bit in Unit 4 that we're going to go over, but there's no test for Unit 4. Surprise, surprise. So you're almost there. You're almost there. Keep fighting. Keep fighting. Doing good. All right, in this one, we're going to be talking about fractional exponents. So we can represent square roots, cube roots, and all radicals of fractional exponents. A big word. When we square something, we have an exponent of 2. When we square root something, we actually have an exponent of 1/2. So with that being said, with any radical, we're going to start seeing more numbers out here. It's not just going to be a 2 or a 3. Actually, we don't see a 2. It's assumed to be a 2. We won't see a 3. And we'll see more numbers in here. But this can be written as x to the b over a. We'll work with that more as we get through this unit. So knowing that, what we talked about, what is the value of each expression? So we have 8 to the 1/3. What this really represents is just the cube root of 8. Cube root of 8 is which number multiplies to be 8. Which number multiplies 3 times to be 8? That would be 2. That's it. So 16 to the 1/2 just means we have the square root of 16. It's like it's a 2 out there. 16 to the first power square root of 16 is 4. Yeah. 81 to the 1/4 really means the 4th root of 81. So what number multiplies by itself 4 times to be 81? Well, that would be 3 times 3 times 3 times 3. 3 to the 3rd is 27. 3 to the 4th is 81. So that would just be 3. Cool. All right, now we're going to start getting into some variations. So here, notice I have an exponent. So this really represents 6 to the 1/2 times 6 to the 1/2. You learned in Algebra 1 that as long as you have the same bases, you can add the exponent together. Well, 1/2 plus 1/2 is 1, so this is just 6 to the 1st, or just 6. That's it. Another way to see this, the way that I usually look at this, is that I have these multiplying together. 1/2 times 2, these will divide to make 1, so again, I just have 6 to the 1st power. Same thing. Here, we're using the same sort of idea, 3 to the 1/2 times 3 to the 1/2. They have the same base, so I'll add them together, so it's just 3 to the 1st power. -9 to the 1/2, so that is the square root of -9. Well, that creates imaginary solutions. So we're not going to work with these right now, and we are just going to say this is imaginary or not real. Right, imaginary, not real, same thing. Okay. Even tougher ones. But still, they're not too bad. So if I multiply these things, this is 64 to the 3 over 6. Right, just multiplying straight across. 3 over 6 will reduce to 1 over 2. 64 to the 1 over 2. I know if I'm taking it to the half, that's the square root. The square root of 64 is 8. Done. Do another. 49, we have 6 and we have 1/12. So 49 to the 6 over 12, which is 49 to the 1 over 2. Square root of 49 is 7. Done. 729 to the 5/6. So here's one that I like to rewrite. 729 is 3 to the 6th, I do believe, on the calculator. Like my song? It's okay, I know it's a terrible song. All right. So one thing, yeah, you could probably just type in 729 to the, what are we doing? 5 divided by 6, 5 divided by 6. Whoa, look at that, it's 243. So you could even check these in your calculator. So if it doesn't work for you, you guys should be able to check them. But just know, especially if you're going like pre-AP track, these are ones that you're going to have to do without a calculator. But I just wanted to check that 729 was 3 to the 6th. Look at that, it is. So this is the way that I work these. Since I know 729 is 3 to the 6th, this is 3 to the 6th, and I still have that 5/6 on the outside. Well, if I multiply these, 6 divided by 6 will make 1. So really I have 3 to the 5th, which, hey-oh, we cheated, and we know is 243. Probably your school won't make you memorize ones that big, but maybe, who knows, who knows. Especially if you're in UIL, you will definitely have to know those. All right, 16 to the 3/4. So I tried to find the smallest base I can. So I know I can rewrite this as 2 to the 4th to the 3/4. So 4 divided by 4 makes 1, so this is really just 2 to the 3rd, which is then just 8. That's it. All right, so here, I notice I have another negative, but look at our root, it's a 3. We can take roots of 3, 5, 7, 9 of negatives, and it still be fine. It's only when you have an even number root, remember. So this negative 27 is negative 3 to the 3rd, and I still have that 5/3 on the outside. 3 divided by 3 makes 1, so this is negative 3 to the 5th, which we know would come out negative 243. Cool. All right, here. Well, check that out. We have fraction. So, still, you can multiply these across. 4 divided by 4 will make 1. So this will come out as 8 to the 1/3. Well, that's just the cube root of 8, so what number times itself 3 times gives us 8? Well, that would be 2, just like we did in the very first example. Whoa, wrap around. All right, moving on. With m, 256 squared to the 1/8. Simplify these things first. This would be 256 to the 2/8, which will reduce to 256 to the 1/4. So that's what number times itself 4 times is 256. Well, that would be 4. 4 times 4 is 16, times 4 is 64, times 4 is 256. That's pretty much it with the fractional exponents. We're just going to be simplifying a little bit more as we go now. But that's really the tough part. So write each as an algebraic expression without a rational exponent. So this is a square root of 8 to the 4th times 8 to the 7th. Remember, we multiply these, or add these things together. So 4 plus 7 is 11. Since there's not a number written on the outside there, there's no number on the outside of my root, that it represents a 2. So this is just a to the 11/2. That's it. So these, add them together, square root of b to the 20th. 20 divided by 2 is actually 10, so I can just represent this as b to the 10th. X to the 7/5, I'm actually going to represent these as a root. I'm sorry, we're using different directions than I did in writing. But the bottom number is the root, so I have the 5th root of x to the 7th. You could also see this written as x, 5th root of x squared. So think about that. It's saying groups of 5. Well, in 7, there's one group of 5, and there is 2 left over. So I leave 2 on the inside. I could take out 1. All right, same sort of idea here. The bottom number is my root, so 3rd root of a to the 5th. And look, there's one group of 3, so I can take 1 out, and I'm still left with a remainder of 2. Either way you want to write that is fine. Apex could give you either one as well. All right. Write each value as a product. All right, I'm going to have to come back and finish this later. We got to go somewhere. I'll talk to you soon. Well, you don't even know. I'm going to come back in like half a second. All right, and we're back. Little do you know, I've actually been gone for 5 hours. No, we got to see our little kid, so that was exciting. All right, write each value as a product. So we were talking about exponents. So this is something, it doesn't really come up very much, but Apex is going to ask you questions about it. So I want to make sure that you saw it. So we have 3 to the 2.73. You can come up with what value this really is. What Apex is going to do is they're going to say that, because if we take a 2.73, that's the same thing as 2 plus 0.7 plus 0.03, right? So they're going to take these as the exponents. So 3 to the 2nd times 3 to the, they're going to make this 0.7 as 7/10 times 3 to the 3/100ths. So 3/100ths. That's how they're going to split it up. So similarly, do another one. 3.716. So they're going to do 2 to the 3rd times 2 to the 7/10 times 2 to the 1/100th times 2 to the, now this is 6/1000, which is the same thing as 3/500. So you could see either way. My guess though is they're going to reduce that to 3/500 because it's in the thousandth place. All right, but that's pretty much it. Again, this isn't going to really come up too much in math. I've never really seen it, but again, it's on your quiz and on your test, I believe, so I just want to make sure that you saw that. All right, so solve each equation. Now we're dealing with fractional exponent equations. So still we're going to kind of do the same thing. Whenever we had the square root of a x or something like that, we would square both sides. We're going to do the opposite fractional exponent to both sides in order to help us solve this. So if I have x to the 2/3, what I can do is if I raise it to the 3/2, that would make 3 divided by 3 to 1 and 2 divided by 2 to 1. So what I do on one side, I have to do to the other. So 3/2. Notice also, we have a 2 in the denominator here. Anytime you have a 2 in the denominator, you got to put the plus or minus. So that's just like saying, if I had x squared equals 9 and I take the square root of both sides, right, which is the same thing as 9 to the 1/2, notice that's an even number down there, this would come out plus or minus 3. So similarly here, we'll have x equals plus or minus 3 to the 3/2. You can type this in, figure out what number it actually is if you would like to. Let's see, 3 to the 3 divided by 2. So that would be 5.196. But I'm just going to leave it as 3 to the 3/2. So that would be our solution. X equals plus or minus 3 to the 3/2. Again, you could also write it as the decimal that I showed. All right, last two examples. So notice in this one, our fractional exponent is just on the x. It is not attached to the 4. It is not with the 5. So the first thing I'm going to do is add the 5 to both sides such that I have 4x to the 1/3 equals 8. And then I'm going to divide both sides by 4. So x to the 1/3 equals 2. And then here I can cube both sides so that x equals 8. So notice that was like 3/1, so I don't need the plus or minus. So that's it. Alrighty. All right, this next one, one example comes up on the quiz. It doesn't come up on the test, doesn't come up on the exam at the end of the semester. But I did want to show you so that you could get like the free 2 points or whatever. So this one is a little bit tricky. It kind of threw me off at first, and I don't usually get thrown off too much by this stuff. So it is kind of tricky, but something that you have to notice here is that I have an x to the something over 4, x to the something over 4, x to the 1/4. So what they want you to do here is factor out this x to the 1/4 such that this becomes x to the 8/4 minus 5x to the 4/4 minus 6. Well, if we think about those numbers on the inside here, 8/4, that is 2. 4/4 is 1, so it's just a quadratic, where all that they were trying to get you to do was factor out that x to the 1/4. So this is x squared minus 5x minus 6 equals 0, which we can factor. Right? That's x minus 6 and x plus 1 equals 0. And I still have x to the 1/4 on the outside. So now with this, I have 3 factors that multiply to be 0, so they each must be equal to 0 for that to be true. So x to the 1/4 equals 0. X minus 6 equals 0, and x plus 1 equals 0. So with this one, if I take it to the 4th power on both sides, that means x equals 0. Add the 6, so x equals 6. Subtract the 1, so x equals -1. All right, and that's it. So biggest thing to notice here was this first step here, where I factor out the x to the 1/4. If you do that, it makes the problem a lot easier for you. Other than that, congratulations on being done with Unit 2. Let me know what questions I can get for you guys. Don't forget to do your practice assignment and turn that into me. Let me know what I can do to help you. I'll talk to y'all soon. Bye.